Our lesson this week involves rational exponents, but before you can learn rational exponents, let's go over what radicals are. So you could have like the square root, cube root, fourth root, etc. Whenever you take the root of something, it's the opposite of raising it to a power. Okay, you're finding the root of that number. So let's start with the square root. There's really this invisible 2 out here. Okay, we don't have to write the 2 because it's just commonly known that that's the square root. So we would ask ourselves, what number would you multiply by itself twice to get 100? And so that would be 10, because 10 to the second power, 10 times 10, is 100. All right, let's look at the next one. The cube root of 8. So you would ask yourself, what number do I multiply by itself 3 times to get 8? And that would be 2, because 2 to the third power, 2 times 2 times 2 is 8. Now the fourth root of 81. So what number would you multiply by itself 4 times to get 81? And that would be 3, because 3 to the fourth power is 81. All right, last one involves a negative. What number would you multiply by itself 5 times to get negative 32? And that would be negative 2, because negative 2 raised to the fifth power is negative 32. All right, so let's look at some other examples if I was to write these as rational exponents. So for rational exponents, this is the rule. If I have a number raised to a fraction, the numerator, this a, is the power. Oops. There we go. And the denominator is the root. Okay, so I think of it kind of like a tree. A tree gets its power from above, like the sunlight. Okay, so your a becomes the power, and then your root is the denominator, because a tree grows its roots into the ground. So let's look at some of these examples that we just did on the previous page if I were to write them as rational exponents. So for this first one, 100 to the 1/2, my root would be 2, because it's the number on the bottom in the denominator. So this would be the square root of 100. Your base always goes under the radical. And then my power would be 1. Okay, remember that we don't have to write this little 2 here. So this is really the square root of 100. Okay, the square root of 100 is 10. And then this would be 10 to the first power, which is just 10. Okay, moving on to the next one. So my root is 3. So this would be the cube root. My base goes under the radical. And then my power goes up top. So this would be the cube root of 8 to the first power. So the cube root of 8 is 2, and then 2 to the first power equals 2. All right, next example. So I would have the fourth root, because 4 is in the denominator, of 81 raised to the first power. So the fourth root of 81 is 3, and then 3 to the first power is 3. Okay, last one. This would be the fifth root of negative 32 raised to the first power. So the fifth root of negative 32 was negative 2, and negative 2 to the first power is negative 2. Okay, so that just explains how you go from a rational exponent to a radical. Now let's look at some of the IXL examples you will see. Alright, so 1 to the 1/3. Okay, I would rewrite this as a radical. So my root is 3. I put my base under the radical, and I would raise it all to the first power. So this would be the cube root of 1, which is just 1, raised to the first power. So this would equal 1. Okay, let's do the next one. So this time my root is 4. So this would be the 4th root of 16, all raised to the first power. So I'd have to think, what number would I multiply by itself 4 times to get 16? And that would be 2. So this would be 2 to the first power, which is just 2. Okay, for the next one I have 25 to the 1/2. So my root is 2, which remember I don't have to write that 2 out there. So this would be the square root of 25 to the first power. So the square root of 25 is 5. And then to the first power would just be 5. Okay, some of you probably already figured out you could just type these in your calculator. Like I could just type in 25 to the 1/2. But later on, as we start getting into some exponents, you're going to have to know this rule, and you're not going to be able to type it in your calculator if it has a variable. So make sure you're understanding how to go from this process of converting a rational exponent to a radical. All right, last one on this page, I have 243 to the 1/5. So this would be the 5th root of 243 to the first power. All right, so I'd have to figure out, well, what do I multiply by itself 5 times to get 243? And that would be 3. So once again, 3 to the first power is just the same thing as 3. Okay, let's do some more examples. So for these problems, as you can tell, the numerator is no longer 1. So we're taking it up to a little bit harder level. Let me go ahead and use colors again just so we can clearly see what's the root and what's the power. So if I had 64 to the 5/6, my power would be 5 because it's in the numerator, and my root would be 6. So I would be taking the 6th root of 64 all raised to the 5th power. Okay, we always have to think about order of operations here. I want to do what's in the parentheses first before I do the exponent. So I need to find what the 6th root of 64 is. So what number do you multiply by itself 6 times to get 64? And that would be 2. So I know the 6th root of 64 is 2, and then I still have to raise the 2 to the 5th power. So then I would need to evaluate what 2 times 2 times 2 times 2 times 2 is. 2 to the 5th power, and that would be 32. All right, next one. So my power is 3 because I have 4 to the 3/2. My power is 3, and my root is 2. So this would be the square root, which there's a little 2 out there, of 4 all raised to the 3rd power. So the square root of 4 is 2, and then I would raise 2 to the 3rd power. So 2 cubed would be 8. All right, last one on this page. I have 16 to the 5/4. So I would take the 4th root of 16 and raise it all to the 5th power. So I would have to figure out what number do I multiply by itself 4 times to get 16. And the 4th root of 16 would be 2. And then 2 to the 5th power, once again, we just did that up here earlier, would be 32. Alright, for the last set of examples, this involves a negative exponent or a negative base. So for this first one, everything still stays the same. I would have the 6th root of 64. But this time I have to raise it to a negative 1. So the 6th root of 64 we know is 2. And then I would still raise it to the negative 1. So remember that a negative exponent does not mean a negative number. It's actually just written as a fraction. So I would turn this into 1 over 2 to the positive first power, which is just the same thing as 1 over 2 or 1/2. All right, for the next one, I would have the 5th root of negative 243 all raised to the negative 1. So the 5th root of negative 243 is negative 3. and I would raise that to the negative 1. So I need to rewrite this as a fraction, okay? If you are struggling with negative exponents, don't be afraid to check yourself in the calculator, okay? You could type in negative 3 to the negative first power. Just make sure you always put a negative in parentheses if you do need to check yourself. So I would write this as 1 over 3 to the positive 1, which would be the same thing as 1/3. Okay, last example and you are done. So I have the fifth root, again, of 243, but this time I'm raising it to the negative 6th power. So I already know, just because of the last problem, the fifth root of 243 is positive 3, and then I would raise positive 3 to the negative 6. So this would become a fraction. I could rewrite this as 1 over 3 to the positive 6. So this would be 1 over, and then I would evaluate 3 to the 6th power, which is 729, okay? And it would want me to leave my answer just like this in fractional format. Don't convert that to a decimal. All right, that's all for today. Hope you guys have a great week. Let me know if you have any questions.